In this video, we are going to look at reaction types, but using them to write balanced chemical equations. And we're going to be doing this from pages 10, 11 in your homework packet, giving you an example to look at so you can do for each particular type of reaction. Okay, so the first thing I'm going to do is look over here and I'm going to complete the word equation, and then the big thing, I want to write out the right chemical equation. So the first one is a synthesis or composition reaction, and that's when smaller things come together to make something bigger. So your 2 all beef patties, special sauce, lettuce, cheese, pickles, onions, and sesame seed come together to make a Big Mac. Or maybe we don't have to have 7 ingredients. Maybe we just have 2, lithium and fluorine are going to make lithium fluoride. And I think I'm going to write that in right here. And just complete the word equation like this. Notice the "ene" goes to the "ide" ending when we do the formula. And yes, that is an ionic formula because lithium is a metal, fluoride is a non-metal. Okay, next thing is I'm going to write out a balanced chemical equation for this. You know, what I might actually do, I think I'll just do that. Okay, so lithium is, I think I'm going to draw this one in here, is Li is a symbol for lithium. Is it part of Brinkelhoff? No, so it doesn't travel in pairs, so that's going to be by itself. Fluorine is part of Brinkelhoff, so we better pair that one up. And then we got to go lithium fluoride. So I'm going to do an Li plus an F. Whoops, I'm sorry. I don't need to do that. They're compound, not separate things. Let's try that again. And what's the charge on Li? Well, if I look on my common ion chart, I'm going to see that, or I'm going to look at my periodic table, and I'm going to see lithium is in family 1 right here. So you can see it's going to have a +1 charge. It's an alkali metal. And fluorine is in family 7. It has a -1 charge. You could also find that by looking on the common ion chart, but I think I'm going to just do it the way that I did it right there. Okay, so I'm going to just make note of this, that this was a +1 here for lithium, and fluoride was a -1. So this is the right balance formula. So notice I can't just take the 2 and put it over there. I got to get the right chemical formula first. This is lithium, goes by itself, fluorine goes in pairs, and then lithium fluoride is the right thing. Now I can put numbers in front to balance the coefficients. And I look here, what's different? I have 2 fluorines here, so I put a 2 in front here, but that gives me 2 lithiums, so now I put a 2 in front right here. And then you don't have to put the 1 in, but I'll just do that for emphasis. 2 lithium atoms plus 1 fluoride molecule forms 2 lithium fluoride compounds right there. Okay, so that is a synthesis reaction, smaller things making something bigger, and you get to see the balancing with that. Let's go to the next step here, and let me get my spotlight. I'm probably going to erase some things here. So I'm just going to do that, go to my spotlight, scroll down, and I'm going to do decomposition. And I kind of pre-did this one because I think it's really very similar to synthesis, except in the opposite direction. Given sodium chloride, and notice what it says, assume the compound breaks into its component elements unless stated otherwise. So that's real helpful for this. So sodium chloride is going to break up into sodium plus chlorine. And I'm going to say, oh, what's sodium chloride? If I look on my common ion chart, I'm going to find out sodium has a +1, chloride has a -1. So that's balanced the way it is. Sodium is not part of Brinkelhoff, so it travels by itself. Chlorine is part of Brinkelhoff. Okay, we see it right there, travels in pairs. So that one travels in pairs. And so I get my right chemical formulas first. Now I look at it and say, oh, Cl2, I need to put a 2 in front there. That gives me 2 NAs. I have my balanced equation. So again, very similar to the balancing for synthesis, except it just goes in the opposite direction. But we see a lot of commonalities there. Okay, let's go to the next reaction, which is a single displacement. And that's going to be zinc plus copper chloride. So a single entity and a combined entity. Well, the zinc is going to replace the copper or chlorine. Well, metals replace metals. So this is an ionic compound, copper chloride, a metal and a non-metal. So you're still going to get another ionic compound, this time the zinc combined with the chloride. So it's like the copper's dancing with the chloride, the zinc comes in, kicks the copper out. Now the copper is over by itself, and then we have the zinc chloride. So I'm going to draw that in here. I'm going to write that in here and just in words. And I'm going to say that's going to form, let's see, we'll say copper because that got kicked out, that got displaced or replaced, plus zinc, and then it would be chloride right here. All right, now we're going to write the balanced equation for this. Zinc is not part of Brinkelhoff. That's a Z, not a 2, by the way. So we got zinc, and then we got a copper, which is Cu, and it's plus 2 in this case. In chloride, I think we established already that that is Cl with a -1 charge. We established that was -1. So if you have a plus 2 and a -1, this has got to be a 2 down here. Okay, that's going to form copper. Copper's by itself. It's interesting, something when it's by itself doesn't actually have a charge, only when it's in the ions it does that. So like the zinc and the copper, when they're by themselves in this equation, they actually don't carry a charge with them. Okay, and then the last one would be zinc. And how do I know what the charge on zinc is? I don't. Let's see. I know Cl is -1. I don't know what zinc is. I'll look at my periodic table. Well, that doesn't tell me anything because it's a transition metal. Maybe I'll go to my common ion chart. Let's try that. I think that'll work. Okay, there it is, zinc plus 2. All right, so we have it down there. Now we know that, and I'm gonna roll this back up here. I think we're pretty good. If zinc is plus 2 and Cl is -1, then this has got to be a 2 right here. I have a zinc here, I have a zinc here, I have a copper here, I have copper here, I have 2 Cls, 2 Cls. Well, it's already balanced, okay? So I didn't carry this 2 over necessarily. I just so happened to work out that way because zinc is plus 2, just like copper is plus 2. Okay, so that would be a single displacement. Remember, the metal replaces another metal in there. Let's look at a double displacement, and I'm going to go to that right here. Let's scroll down. Probably have to clear that out. And let's go. And this would be silver is a positive ion, nitrate's negative. Sodium's positive, chloride's negative. We're going to do the partner switch. Positive to this negative, this positive goes to this negative. So I'm going to write this in text form. Let's do that quick and say that's going to form, say LVER. Silver nitrate. Looks like I got room to do this here. I'm sorry. Let's try that again. Silver chloride. And then I'm going to say plus sodium nitrate. Okay, it didn't quite fit in there. just get rid of that right here. Okay, I think that looks a little better right there. So notice this positive, this negative, and this positive, this negative. It doesn't matter if I said sodium nitrate and silver chloride, that would be fine. What I don't want to do is say nitrate sodium or chloride silver, because positive ions, think positive, positive ions comes before negative. Okay, I can look at the charges of these things, and I'm going to look this up. Actually, I'm not going to. Common ion chart, silver is +1, NO3 is -1, sodium is +1, Cl is -1. So I'm going to cheat and do that so I don't take a long time with this. And silver nitrate's therefore going to be Ag is +1. This whole thing, NO3 is -1, and I got that from the common ion chart. I don't think I'm going to go and look that up, but I'm going to do that and say Ag, NO3 is -1. And then what happens is this Na is +1 and Cl is -1. So what's going to happen? What is it going to form? It's going to form Ag Cl. And you still got a +1, -1. And then the last thing is going to be sodium nitrate, which would be, oh, I'm doing that wrong. I'm feeling sodium for messing this up. Let's try this and call it Na. And then the nitrate would be NO3. And again, you don't have to rope off the NO3, but I like to do that just to see what's going on. And this positive with this negative, this positive with this negative. Because everything was +1 or -1, the balancing was pretty easy in this example. Okay, one last piece I'll show is a combustion of a hydrocarbon, and I'll do this one here. Hydrocarbon plus O2 forms CO2 plus H2O, and I think we've done a couple examples with that, but you can take a look, one carbon, 4 hydrogens, and here's the trick. 2 oxygens plus 2 more oxygens give me 4 oxygens. 2 times 2 is 4 oxygens on this side. All right, try these on page 10 and 11. And there's a key for most of the answers so you can check over and see how you're doing. Thank you.